Hello students, here we are back in Unit 2. Today we're going to be starting lesson number 16. So see, lesson 16, solving systems by elimination, and this is the third part of this. And so we're going to be continuing on, giving you more examples and showing you a little bit different ways to look at stuff. So we're going to go and start out with, we have these two equations here, all right? You got 4x plus y equals 1, that's considered equation A, and x plus 2y equals 9, equation B. So we're going to go and try to go and use these, if you will, to solve for the solution. In other words, the place where that they will be intersecting. Okay. So if we just start with those, there's a lot of things that hopefully you'll still remember how we did the various math things. Okay, so let me just write these down here. And we'll do a little bit of talk before we actually dive into these problems. Okay, and so let's go over here. All right, so here's our two equations. All right, so a couple things I want you to notice again. Let's look at what the values of things. I want to find the slope and I want to find the y-intercept. All right, and that'll give me a big clue as to what I'm looking at here. So as you remember, the slope for these things is going to be a negative a divided by b. So on this one, if we look out, we'll have a negative 4 divided by 1. So it's a negative 1/4. And if you look at this one, I'll have a 1. There's a 1 right here. You don't see it's a stealth 1, but so it'll be a negative 1 divided by b, which is 2. So the slope there is negative 1/2. So as you can see, the two slopes don't match. They're not the same. And so you can always just assume that they must intersect then if they do not have the same slope. Okay. And we'll go over here to the y-intercept. If I put in a 0 here for the x, then I have y equals 1, and that just tells me that the intercept here is at 0, 1. And on this one, I have, if I put in a 0 into where the x is, then I'll have 2y equals 9. Well, if 2y equals 9, you divide by the coefficient of the unknown, which would be 2. So it's 4.5. So here it's at 0, 4.5. So as you can see, they have different y-intercepts. They have different slopes. So they will be having a point where they actually go through and have an intersection. All right. So let's go through these problems a little bit here. Now on the problem set, they wanted you to go ahead and take these. Let me move myself out of the way here. Use the graph technique to graph the equations. You can do that on your own. Giving you the slope and a y-intercept, you should be able to figure these out. Write a few equations. They're listed to equation A by multiplying both sides of the same number. For example, 2, -5, or 1/2. Let's call the resulting equations A1, A2, A3. Record your equations. So we're going to take this A equation, we're going to multiply everything by 2. Then for the second one, we're going to multiply this one by 5, or excuse me, -5, and then this top one by 1/2. All right. So let's go and see what those look like. So if I start out with, so let me go and write down a few things here. All right. So I've got 2, -5, and 1/2. That's what I'm going to be looking at. All right. Let me go back to my camera. All right. So what we're going to do here is we're going to take these numbers and just multiply it through this first one. So if I take 4x plus y equals 1, and then this first one I'm going to multiply everything by 2. All right. So 4x times 2 is 8x. 1y times 2 is 2y, and then 2 times 1 is 2. Now I want you to notice something here. This is the exact same equation as that, and I can prove it because they have the same slope and they go through the same intersection point. Let's look at this. What's the slope here? Well, it's -8 divided by 2, which is a -4, which is the same slope as what the original was. If I put the y-intercept in here, I put a 0 in here, that's 2y equals 2, well then y equals 1, just like before. So this is just another way to state the exact same equation. You didn't actually change the equation. You just simply made things twice as big. All right, that's the beauty of these things. If you multiply both sides of the equation by the same number, you'll maintain an equality. So what was true before will be true again. All right. So this right here is what you'll have for A1. All right. So let's move on to A2. So we're going to take that same 4x plus y equals 1. And this time I'm going to multiply everything by a negative 5. So 4 times a negative 5 is a negative 20x. Negative 5 times a 1 is minus 5y. And negative 5 times 1 is a negative 5. Let's go through this again. Does it have the same slope? Well, I do a sign change and then a negative 20 divided by a negative 5, which is b. So the negatives cancel, and I have negative 20 divided by 5, which is a negative 4. So it's the exact same slope again. And let's find out the y-intercept. Make the x 0. So I have negative 5y equals a negative 5. Well, obviously y equals 1, so it's back up to the same intersection point. You didn't change the equations. You just simply made one, which is the same as that. They actually are the exact same equation. And let's look at A3. Let's see if fractions work. So I got 4x plus y equals 1. I'm going to multiply everything this time by a half. So 1/2 of 4 would be a 2x. 1/2 times 1, that's just 1/2 y. And 1/2 times a 1 here is just 1/2. Okay, let's look at the slope. So sign change of a, so that's a negative 2, divided by b, which is 1/2. Okay. Now remember, when you divide by a fraction, you need to do the reciprocal and multiply. So that's the same thing as negative 2 times 2 divided by 1. Well, that's a negative 4 divided by 1, which is negative 4. So again, we have the exact same slope. And if I put in a 0 here for x, 1/2 times what number equals 1/2? Again, 0, 1. So you can see how if you do this properly, you'll have the exact same slope and the exact same y-intercepts. And you'll have the exact same x-intercepts if you really want to go through and extend this. So you didn't change any of these equations. You just simply rewrote them in another equation that has the exact same constituents or same exact line that goes through this. Okay. So graph each one. If you graph them, you'll find the same slopes and the same y-intercepts. You'll find the exact same. Let's say a line on top of a line on top of a line on top of a line. So, all right. Moving on to 16.2, writing a new system to solve a given system. Writing a new system to solve a given system. So they're going to give you this equation here. Here is a system you solved by graphing earlier. To start solving the system, Elena wrote this. All right, so how should we go from here to here? Well, the 4x plus y equals 1 is this top one. Indeed, she did not change that. And then she took this one, and it looks like she multiplied everything by 4. 1 times 4 is 4. 2 times 4 is 8. 9 times 4 is 36. And then she subtracted 1, the bottom from the top. So 4x minus 4x is 0. 1 minus 8 is a negative 7y. And 1 minus 36 is a negative 35. Okay. What were Elena's first two moves? Well, looks like she multiplied by 4 and then she did some subtraction. That's what she did. Complete the solving process algebraically. Show the solution is indeed negative 1, negative 5, or excuse me, positive 5. All right. So let's go through this thing. All right. So this is what we have so far. We have again 4x plus y equals 1. That's our original equation. And we have a x plus 2y equals 9. And so she has come down to the point of negative 7y equals negative 35. We switch over to camera. All right. And what do we have here? So this is what we've got so far. Those are two original equations. She manipulated the bottom one to go and arrive at this. To solve this, I need to find out what y is. I need to get by itself, so I divide by the coefficient of the unknown. Y is the unknown, negative 7 is the coefficient. So negative 7, cancel. Y equals, well, let's see, negative 35 divided by negative 7 is a positive 5. Now that you have that, you can go and put it into any of these equations. I usually suggest the one that you didn't manipulate, and then also try the second one just to be sure. So let's see, 4x plus 5 equals 1. So I've taken that y and I've just simply substituted into here. So what does that give me? Well, let's see. I need to subtract 5 from both sides. So I got 4x equals, this goes away, and 1 minus 5 is a negative 4. X equals a negative 1. So what's my solution? Well, so far it looks like that's my solution. Let's try on the second one to make darn sure. Okay. So I have a negative 1 plus 2 times 5 equals 9. What's a negative 1 plus 10 equals 9? I can add 1 to both sides, and what do I get? 10 equals 10. So yes, come out with a true statement, so it works. Okay, and that's what's going on there. So we just simply, it's very similar to what you were doing before break. So we'll just continue on from there. All right. And so we kind of talked about this. Your teacher will give you some slips of paper with systems and equations on them. Each system represents a step in solving this system. Arrange the slips in order that will lead to a solution. Be prepared to describe the move and explain why each system is equivalent to the one before it. Okay. I'll let your teacher do that, your para, to do that. I'm actually going to go through and we're going to actually solve this the good old-fashioned way. All right. So let's go ahead and get a fresh piece of paper out. Write down our equations. 4/5 x plus 6y equals 15, and negative x plus 18y equals 11. Okay, so let's go to this one right here. So this is kind of a screwy set of equations. First off, you've got fractions, all right? That's the big thing. First, you've got fractions to deal with. I hate to deal with fractions, especially in this kind of stuff. Whole numbers are easy to work with and think with. So what I'd like to do first is I'd like to get rid of fractions, all right? So if you look at this, the only fraction you really have is here. The denominator is 5. Here, this you could think of this as a fraction. It's 6 divided by 1. Same thing with 15 is 15 divided by 1. And so you have to realize that there's this thing called the least common denominator. It has two purposes in life. All right, we can add and subtract fractions with it, or we can eliminate fractions. All right, eliminate fractions. So if I want to eliminate fractions, I have to multiply both sides by the least common denominator. Well, if you look at this thing, I got a denominator 1, a 1, and a 5. So for that top one, the least common denominator is 5. Right? So I'm going to multiply both sides of this thing by 5 and see what I end up with. Okay, so 5 times 4/5, well, the 5s will cancel, and I'll just get a 4. So that's a, draw the flow arrow here, a 4x. 5 times 6 is 30, so plus 30y. And then 5 times 15 is 75. All right, and then I'll just ratchet this other one over here, negative x plus 18y equals 11. All right. So now your question is, or your problem here is like, do you want to get rid of the x's or do we want to get rid of the y's? All right. Well, 18 and 30 are kind of hard to get rid of because their least common denominator is like 400 and some. So that's the hard way to. Yes, you could do it that way, but it's the hard way. Look at the x's though. If I just took this bottom one and multiplied it by 4, then what would I get? Well, I would get, I'll get another little flow arrow here. I'd still have the 4x plus 30y equals 75. And if I multiplied this thing by 4, I'd get a negative 4x. And then 18 times 4, gee, let's see, what's 18 times 4? 18 times 4, 72. Plus 72y equals, and then 4 times 11, hopefully be able to figure it out in your head, and that's 44. Okay? So now what do we got? All right, so I got this equations here, and if I add this one, if I add it, I can go and get rid of the x's, and I'll just have some y's to deal with. Okay? So what do we got? Let's just add these things together. Well, 4x minus 4x is nothing. 30 plus 72 is 102y. And then if I add this, 5 plus 4 is 9. 7 plus 11 is 119. Okay, so that's a kind of a screwy numbers. Let's go and check my work here. Okay, So at this point, it's like, wow, that's a screwy number. All right, and so I'm going to go and pause here, and I'm going to go back and check my work to make darn sure I didn't make any mistakes, because usually they give us stuff that all kind of nice and cancels out. But with this, I think I might have made a mistake, but I'm going to go and take a look. Okay. All right, and I'm back. I reviewed everything, and it looks like that is indeed what we've got here, the series solution. Now, in the book, what they're trying to get you to do, let me go to it. All right, they just want you to arrange the slips. Apparently, they don't want you to actually solve for a specific number on this one, which is fine. They just want you to go and set a series of steps. So we'll forego finding the actual point of intersection, the solution. That's just not what this problem is designed for, so it's okay. We're at this point, we're just investigating steps, not so much solutions. Okay. So here's another one, 16.4, build some equivalent systems. All right. So here's a system of equations. You've got your A's and B's over here. To solve this problem, Diego wrote the equivalent system in 2 steps. So step 1, look at this one and look at this one. What do you think he did? Well, 12A plus 5B, negative 15. So he didn't do anything to the first one. And we went from 8 to a negative 40. So that means he must have multiplied by a negative 5. And he went from a 1 to a negative 5. So that looks like another negative 5. And 11 to negative 55 looks like another negative 55. So that first step, it looks like he went and multiplied by a negative 5. And why would he do that? Well, he's trying to get rid of these b's right here. All right, by multiplying by a negative, all right, he doesn't have to worry about subtracting. He can just simply integrate that subtraction mechanism in with by multiplying by a negative 5. All right, so he got to here, and then at step 2 is what he came up with. All right. So what did he do here? All right. So I still get 12a minus 5b. You've got 12 minus 40 is a negative 28a. And then the 5b's go away. And then negative 5 plus a negative 55, or negative 15 plus a negative 55 is a negative 70. So this time he adds, because that by adding he'll get rid of this. Ends up with a negative 28a equals a negative 70. And again, that's going to give you kind of a screwy number. They're looking for steps here. They're not looking so much for a solution. Describe the steps. Prepare how to see. Be prepared to explain how steps 1 and 2 have the same solution as the original system. We're taking equivalent fractions this entire time, and we'll always have the same solution. Write another set of equivalent systems different from Diego's first 2 that allow one variable to be eliminated and enable you to solve the original system. Use your equivalent systems to solve the original system. Check your solutions. And again, I'll let your teacher there and Anthony kind of decide how to do that one. You can just take numbers, any numbers that you want, and just start manipulating to solve. All right. So your little summary here. Now we have 2 algebraic strategies for solving equations by substitution and elimination. Right? We've been doing elimination this entire time pretty much. In some systems, the equations may give us a clue as to which strategy to use. All right. So on this one, you notice, what's this form right here? Well, it's a y-intercept. And this form is a standard. All right. So in this system, y is already isolated. We can solve the system by substitution, by substituting 2x minus 11 in for y in the second one. So we can just do a substitution right here. Whee! And then you'll have 3x plus 2x minus 11 equals 18. And so that's this one, because they're 2 different forms, a y-intercept and a standard, substitution might be your better choice. This one, they're both in a standard form. And if you'll notice, you have these things lined up so that the 3x's will, if you add these, will just simply go away. So this system's set up nicely for elimination because opposite coefficients of the x variable. Adding the 2 equations eliminates the x, and you can solve for y. All right. So let's look at this one. Again, 2 standard forms. All right. It doesn't really lend itself to substitution. And elimination might be your best bet because, well, 2 and 3, they don't really have like a common factor up till you get like 6. So you'd have to work with both of them. But if you just take the top one and multiply it by 3, you'll get a positive 9 here. And with the negative 9, poof, it'll go away. So that was a little bit easier with elimination. All right, and so they're basically taking this first equation, and let's see what they do here. They take the top one and they multiply it by 3. Multiply equation A by 3. So 2 times 3 is 6, 3 times 3 is 9, 15 times 3 is 45. All right, and you get these two, the y's go away. All right. All right, you could multiply B by 2/3. All right, it might be a little bit difficult for you to just come off the top of your head to remember how to do that, but it is possible. You can take this one, multiply by 2/3. You multiply by 2/3. 2/3 times 3 gives you a 2x. 2/3 of 9 is a 6, and 2/3 of 18 is 12. So now at this point, you can just do subtraction, and you can get rid of the 2 x's. And then on this last one, they go all out, and they start manipulating both top and bottom. Now here they multiply top by 1/2, the equation B by 1/3, and this is an attempt to go and make the x's the same. All right. So I mean, that's one way to do it. There's nothing, you still have equivalent fractions. You should just start getting into kind of goofy fractions in this one. This is probably like the one I would like do the least. This one would probably be my favorite one to do up here. This one is a little bit more difficult because you have to figure out which fraction to multiply by to get rid of the x's. And this one's very difficult because you have to figure out both equations, or both fractions for these. All right. So what did they do? They took the top one, they multiplied by 3, the 9's cancel, so you got 9x equals 63, x equals 7. Then they take the x and they resubstitute it in to one of the equations, and they get the other part, y equals 1/3. And you can always check it by going into the second one. Okay. When we solve equations by eliminations, we're essentially writing a series of equivalent systems, or systems with the same solution. Each equivalent system gets closer and closer to the solution of the original system. So if you look at this one, and then you look at this one, and then you look at this one, and then you look at this one, they're pretty much all equivalent statements, all right? Because with this, x and y of 7, 1/3 will work for every single one of these. What's 2 times 7? 14. What's 1/3 times 3? 1. 14 plus 1 is 15. 3 times 7 is 21. Minus 9 times 1/3, which is 3. So 21 minus 3 is 18. And if you try these other two, it'll come out the exact same way. Right? And then they go on to some glossary terms. This is what we're always trying to find a solution. You'll notice that the slope of one and the slope of the other is completely different. So you know you'll have just one intersection point, the solution, the point which satisfies both equations. And that's all we have for today. And so thank you again for working with this. And from this we'll go on to, let's see, after this one, we go into practice problems. So chapter 16 practice problems, make sure you do them first and then look at the video. And that's it. Thank you.